Welcome back. In the previous part, we have seen that how we can load the data, pre-process the data and tune the data. We have also seen that how we can train and validate our model. Now we are going to save our model in the form of pickle format. The first thing I'm going to do is that I'm going to create a folder name as model. You can see that there is no folder name as models. So I'm going to create that. This line says that if this models folder already exists, then do not create that. If it doesn't exist, then create the models folder. The next step, we have three things. We have the classifier, we have the vectorizer, and we have the label encoder. We are going to save all these three algorithms into the pickle format. So let me run this code, and we can see that if I refresh this, folder as named as model is created. And you can see that there are CountVectorizer, label encoder, and logistic regression classifier. Now let's start the inference part. For the inference part, I'm going to restart my runtime so that you can see if I am going to call this vectorizer, it will give me an error because my runtime has been restarted. It says that no name vectorizer is not defined. Okay, that's fine. Now I'm going to load these models in the form of pickle format back. For that, I'm going to load these all back. I'm going to load the classifier, the vectorizer, and the encoder. Now if I check the vectorizer, we can see that now I can see the CountVectorizer as my vectorizer. It means that our model has been successfully loaded. In the training part, we have seen that we have used a preprocessor which is actually using the data frame. Now in the inference we only have one string and we are not going to use data frame for only one string. So I'm going to write my preprocess function again but in a different way. So let's see that. But before that I'm going to download the NLTK files again. But this time I'm going to create a folder as NLTK data. You can name it whatever you want. Then I'm going to define where I want to download these files. I've defined a download directory and the name of the directory is the NLTK data. Right now in this phase, the highlighted code, the NLTK files are going to be downloaded in the NLTK data. But I have to tell the NLTK where the downloaded files are. So I have to define nltk.data.path.append. This will tell the NLTK that from where it has to access the file. If you can refresh this, you can see there is another folder as NLTK data. In NLTK data, you can see there are different files, which are stopwords, WordNet, OMW, which we have downloaded. Now let's move to the preprocess again. Unlike the previous preprocessing function where we are using data frame, now we are not using the data frame. So I'm going text.lower to lower the text, and I'm going to use reject re function to remove the digits. Then I'm going to use @user to remove the user. In the training preprocessing step, you have seen that we are using replace function, but in the reject, the replace function is replaced by the substitute or dot sub function. In the similar way, we are going to remove the URLs and the punctuation. After removing the punctuation, we are going to lemmatize the data after tokenizing the data, and also going to remove the stop words. Till this point, our data is in the form of list, so we are going to convert it into a string. You can see that though the way of writing the both codes are different, this preprocessing step that we are going to use in the test phase and the preprocessing step that we have defined in the training, they both look like different. But if you compare, the both are exactly doing the same task. This is I am going to emphasis on that whatever your training preprocessing step, it should be exactly in the test set. No matter how you code the way, but actual functionality should remain the same. So I'm going to run this cell, and now I have defined another function which is predict result. It accepts a text, and the text will be pre-processed first. Once the text is pre-processed, we need to vectorize the text, and for that I'm not going to use fitted transform because this is a test file, test text. So I'm going to use transform. Then I'm going to use classifier.predict, which will give me the prediction of the text. Right now, either it can be 0 or it can be 1. But I need to know now the actual classy, whether it is offensive, off or not. So I'm going to use encoder, which will inverse the digits into the string bank. Make 0 as not offensive and 1 as offensive. The encoder.inverse transform will do that. So let me run this, and if I'm going to say hello, you better to shut your mouth and predict the result, we can see that it's offensive. And if I say hello, how are you, this is not offensive and a not will be predicted. If you are going to use executable files, then you have to know about the system argument. Let me explain this here. I have copied all of the above code which we have seen in the inference path, and I have write it in a file named app.py. These things are remain the same. The only difference is that I have defined text equal to sys.argv1, and the text which are going to be taken by the script passed to the predict result, this function. Let me run this, and now you can see that I have a script app.py. If I open the script, you can see that here is the script. So we are using sign of exclamation in the Jupyter notebook when we are going to use a Python command. So sign of exclamation python app.py. This will call this script, and then we need to pass our argument, which is gonna pass there. So hello, you are better to shut your mouth. So we can see that the prediction is that the sentence is offensive. Now I'm going to save this file in the zip file, so I can download them.